Hello, seventh graders. Welcome to week 3. That means right now in your table of contents, this is what you should have complete. And I just want you to notice right here in my video last week, I had that written as standard 2, which is silly. That was week 1, we completed standard 2 and took our assessment. Week 2 was all about standard 3. So just to kind of recap, week 1 was just about different measures we can use to represent one set of data. So we can do measures of center, we can do measures of variation. Measures of center are mean, median, and mode. Measures of variation were the 5-number summary, the median, the lower quartile, the upper quartile, and we use those to make box plots. So week 1, this second standard of statistics was all about how do we represent one set of data. Last week, week 2, which was actually standard 3, so that's why make sure you can fix that on your table of contents, sorry about that. Page 9 was the project example, standard 3, and page 10 was your final project, which you submitted to me, and I got to watch videos and see you guys, which is awesome. So make sure this is what you have in your table of contents so far. Week 2 was all about comparing. If I have 2 sets of data, how do I compare? And we're still going to do that a little bit this week. But this third week, our next standard, which is going to be standard 4 in this work, the only thing you need to add to this right now is, I'm going to skip a space again to show that we're into week 3 now. This page that we're going to work on right now is called Who is the Better Saver? To help introduce us to one more thing, one more way we can show information in data, okay? And this is going to be on page 11. So make sure you have that filled in your table of contents. Make sure you fix that. Standard 3, that was all standard 3, sorry about that. Who is the better saver? Okay, so we have all these pages filled in 1 through 10. So I am going to jump to this page and I'm gonna call it down here in the corner. This is page 11. That's where we should be now. I hope you're keeping track of things. There will come a point soon where I ask you to take a quick video of all these notes you've been taking, and there will be some bonus points for those that are keeping track of all this. So make sure you're doing that. First of all, title it on your page. Who is the better saver? Get that written down. As always, you can pause whenever you need to for more time to write things. Here's the scenario in this. You and your cousin, so you do need to get this all written down. You and your cousin are saving for a new phone. Your grandma makes a deal with you guys. She says that if you save for the next 6 months, so she's like, okay, I'm gonna help you guys get your phones. I need you to save for the next 6 months. She also asked you to keep track every month of how much you saved. And she's gonna decide at the end of those 6 months, she will give $100 extra on top of whatever you saved. She will give $100 to whoever she decides is the better saver. So that's kind of the question here is, we're gonna look at some data. We're gonna say the 6 months has passed and you and your cousin have been saving for this phone. We're gonna look at this data and we're gonna try and decide who is grandma gonna say is the better saver. So first let's look at the data, okay? So pause if you need to, get that all written down. That should be the first few lines. And then we're gonna skip a line and I'm gonna show you how much you and your cousin saved. So notice we have 1, 2, 3, 4, 5, 6 columns. So when I drew this, I started and I wrote you and I wrote cousin, and then I drew a line in the middle. And then I went 1, 2, 3, 4, 5, 6, 7 lines like that to help you get that formatted out. So all these purple numbers across the top, this means that in month 1, you save $50, in month 2, $52, month 3, 4, 5, and 6. So there's your 6 months of savings. That's how much you saved every month, okay? Your cousin, those numbers there show how much your cousin saved every month. So take a second to get those written down. You are the numbers in purple. That's your 6 months of savings, and your cousin is those are the numbers in blue. Now, one of the things, so you might be looking at this data and thinking, how is my grandma going to decide who is the better saver? So one of the first things that people think of is, what if we look at the total amount that I saved versus my cousin saved, and we just look at who saved more? That could be a simple way of seeing that. So you can take a second and do this with me, but I am just going to add up how much I saved. So look, I added up all 6 of the numbers on there and it shows me that I saved $312. Okay, so now I'm going to add up my cousin, 40 plus 22 plus 45. I'm just adding up their savings. And oh no, you both saved $312. And you know what else that means is if we come down, we're going to write, I'm going to skip a line and I'm going to put a couple more pieces of information here. That also tells us if I calculate one of our measures of center that we learned in the last couple weeks, which is the mean. Remember, the mean is when you add them all up, which we already did, and got 312. And then what do you do after that? Because 312 is not the average. Oh yeah, we divide by 6 because you were saving for 6 months. So if I do 312 divided by 6, that means my average was $52. But guess what? If your guys' total is the same and you guys save for the exact same amount of months, if you try to calculate your cousin's mean as well, it's also going to be $52. Now, your grandma is a statistician. Okay, if you didn't know that about your grandma. And she looks at this and she says, well, they both saved the same amount and they both saved the same average over the 6 months. They both saved an average of $52 a month. Well, I don't want to give them both $100. So guess what? To help your grandma decide, she needs a brand new measurement. We need a new measurement. Sometimes a measure of center is not enough to make a good comparison. And in this case, it's certainly not helpful because it's exactly the same for both of you. You and your cousin saved the same average amount. You have the same mean. So let's get a brand new measurement. And this is what our next statistics standard is going to be about this week, is practicing something that shorthand, we call it MAD. Okay, but of course MAD stands for something. So I'm going to draw an M here in purple, just so it stands out. And then I'm going to write the rest of this word with blue. That first M, as you can probably guess from what we did up here, the mean is definitely involved. So make sure you understand that the mean is an average when you add them all up and divide by how many there are. We've done that hopefully a lot over the last couple of weeks to help you understand that. So the next letter is A, and the A stands for absolute. Okay, and that makes you think of like absolute value, hopefully. Absolute value means distance from 0, and in practice, what absolute value does is mean you can ignore all the negatives. That's what that part means. So if negatives come up in any of this work, you don't worry about the negatives, you just drop the negatives, okay? And then the last letter here is D. That's why it's MAD. And this word, this is a fun, fancy word. This word is deviation. Do you know what it means for something to deviate? Deviate means to not fall exactly where it's supposed to fall. Deviate means you're off from something, you're different from something, okay? So let's keep formatting this and let's give ourselves a little bit more explanation here on what this means. I'm gonna use green here to tell myself the mean absolute deviation, or MAD. You can practice saying that with me. I'll say mean absolute deviation. Now you say it. Mean absolute deviation. MAD, what this is all fancy words for is it tells us how far, we're going to learn how to calculate this, but mean absolute deviation is how far does all of the data, how far does the data deviate from the mean? And what we're asking when we say that is we're saying how far away is every individual data point. Okay, so I know the mean. So up here, the mean is 52. I know that. My question then is, how far is all of your data from 52 and how far is all of your cousin's data from 52? Now, if you just look at the individual data lists, I just want you to think about for a second, who do you think overall is closer to the mean month to month? Are you closer to the mean of 52 or is your cousin closer to the mean? And you probably have a guess on this and you're going to see how this plays out mathematically. And I'm just going to take my black pen and I'm going to put all 3 of these lines in a nice big box so that it stands out as one of our important vocabulary words for this statistics stuff. This is one of your overall 7th grade statistics standards that's important for you to know, and that's why we're going to work on, this is what we're working on this week, is this idea of MAD, mean absolute deviation. Once I know the mean, I can then figure out how far off is all my data from the mean? And that turns into a really useful statistic. So I'm gonna make a couple tables down here to help map out what's going on with the MAD, okay? So here's our new measurement. It's called MAD, mean absolute deviation. I am going to do a table right underneath this that starts like this. I'm gonna write the word U. This is U in your savings. And I'm gonna count down, there's one space, and then I need 1, 2, 3, 4, 5, 6 spaces under that for all 6 of the months. 1, 2, 3, 4, 5, 6. And I'm even gonna write over here so that I remember this is just for the 6 months that I was saving. Now I'm gonna do a cross like this. I'm gonna skip a little space there, draw another column there, and I'm gonna write diff for difference here. Okay, here's what goes in the middle of this, because mean absolute deviation is how far does this stuff deviate from the mean. So I'm gonna just remind myself all the way down this. I know the mean, I calculated up there, it was $52. So I'm actually gonna write that same mean all the way down this middle column, because my question for all 6 pieces of data is, how far was I from this mean? Okay, now I'm gonna skip some space over here and let's get this set up for your cousin. So your cousin's data was all in blue, so I'll make this data in blue as well. So I'm gonna write cousin here, and I'm gonna go down for the 6 months, 1, 2, 3, 4, 5, 6. I'm gonna skip that space in the middle. I'm gonna draw a line across here, and then I'm gonna write difference over here. And then the same thing goes in the middle here, because your cousin's mean was exactly the same as yours, which is why that piece of data wasn't especially helpful for us. The mean does not have to be the same in both groups for you to calculate this. You can calculate this with whatever the mean is. So for you, let's go back through and actually put, and I'm just copying this from the table. So we need our actual physical data from all 6 months. So if I look back up at the table up there, my first month was $50, then $52, then $55, then $50, $55, and $50. So that is just the original data. I didn't calculate that, I just copied that again from the table. I can do the same for my cousin's data. This is how much they saved every month: 40, 22, 45, 120, 35, 50. So there's my cousin's data. And now I am going to actually calculate the deviation from the mean. How far away was I? Now that's just subtraction. So watch what happens. I'm just always gonna subtract this from this. 50 minus 52 is -2, but the absolute part tells me I get to ignore all the negatives. I subtract, and if there's any negatives, I just drop them off. So 50 minus 52 is -2. The difference I'm concerned about is just 2. Just worried about 2. 52 minus 52 is 0. On that month, I was exactly at the mean. 55 minus 52 is 3. 50 minus 52 is -2. Drop the negative. 55 minus 52 is 3. And 50 minus 52 is -2. Once again, drop the negative. So this is your actual data. This is the mean of your data. And this is how far every single data point was from the mean. Same thing for your cousin. This is all your cousin's data. This is the mean of your cousin's data. Now let's subtract and find the difference. So 40 minus 52 is -12. Just drop the negative. 22 minus 52 is -30. Drop the negative. All the negative or positive tells you is whether you were below or above the mean. But when it comes to the MAD, we don't worry about any of the negatives. 45 minus 52 is -7. Drop the negative. This is the only month you were actually, your cousin was actually above the mean. 120 minus 52 is 68. They were way far off from the mean on that one. 35 minus 52 is -17. Drop the negative. And 50 minus 52 is -2. Drop the negative. Okay. This is not even the MAD officially yet. Okay. One more thing we have to do to calculate the MAD is now we add up all of these numbers. And that's why the word mean is still in this, is because we use the mean and find the difference, and then we calculate the mean again, but now we're calculating the mean of the deviation, of the differences. So I just add up these numbers: 2 plus 3 plus 2 plus 3 plus 2. And if you add those up, you can add them up and verify. but the total of the differences is 12. Let's add up your cousin's differences. The total of your cousin's differences is a lot more than 12 because they were a lot farther off from the mean most months. So their total is 136. Now to actually calculate the MAD, we have to do just like we did up top. We got that 312. Okay, you saved a total of 312. You saved a total of 312. We had to divide those by 6 because it was over 6 months. We have to do the same thing here for mean absolute deviation. So we found the totals. We now have to divide by 6. That number will always be the same as what you divided by to get the mean because you haven't changed the amount of data. You still have 6 total data points. Just now, instead of adding up the actual physical data, we are adding up how far was it from the mean. So just to recap, here's our data, here's our mean. We subtracted and found the difference of every single data point from the mean. We added those up, and now we're about to divide those by 6. Here's your cousin's data. That's their actual physical data. This is their mean. This is the difference from the mean. We're adding those up now and also dividing by 6. There's still 6 data points, so we're still dividing by 6. So this tells me the MAD for you, the mean absolute deviation for you is 2. And we'll talk about what that means in just a second, but your mean absolute deviation was 2. For your cousin, 136 divided by 6, it comes out as a decimal. You can type it in your calculator. I'm just going to round it to 22.7. Now, I hope you notice right away that your cousin has a much larger MAD than you do. Your cousin has a much larger mean absolute deviation. So the question is, what in the world does that mean? Okay, so the first thing we're going to do is just draw a quick little visual representation. I'm going to come here in the center of this line right here. And I'm just going to tell myself, I'm just going to draw a vertical line across 2 rows like that. And I'm just going to say, okay, this is where the mean is. Let's say this is the mean. The mean is $52. If that is the mean, which we know it is, that's the measure of center for this. Again, I'm going to color code this. I'm going to use purple to show for myself, okay? For me, let's say I draw a little tiny little thing. This is, your MAD is 2. That means your variation or your spread in your data is within 2 on either side of 52. So 52 minus 2 is 50. And 52 plus 2 is 54. So it's like all of your data really was spread pretty much between 50 and 54. And I know you look at it and you're like, I got a couple of 55s, but the MAD really just kind of takes that central value, averages out your differences from that central, and tells you your data was pretty much within 2 of the mean the whole time. Where look at this compared to your cousin. So your cousin is like 11 times that, right? 2 times 11 is 22. I don't know if I can fit 11 of those, but if I imagine that, your cousin spread is more like this, okay? So if the mean is 52 and I add, 22.7 to that, that means your cousin's spread, so it's 22.7 above or 22.7 below. So your cousin's data is way more spread out. Your cousin was all over the place in their savings. Sometimes they're like, oh, I only have like 20 bucks this month. And then other months they're like, I have $122. They were all over the place. So this, your cousin's goes maybe somewhere between 74.7 and 29.3. So your data was way less spread out. Your data was, and so, okay, go back to the original question then. Your grandma's looking at this and she's saying, who was a better saver? Well, if we were in class, I would ask you guys who you think the better saver is. And the fact is I would get different answers, and that's okay. Statistics is like that sometimes. But if I'm your grandma, I would definitely at least say that you, what does better mean? I don't know. But I could say you were a more consistent saver. And maybe I consider that better because maybe you planned a little better. Maybe you had a plan. It seemed like you said, I'm going to save about 50 bucks a month. And then you stuck to that plan. Where your cousin was a lot more all over the place. So I think you could argue this either way, but a big thing I want you to make sure you are clear on is that MAD is yet another measure of variability. It helps us understand, once again, how is the data spread. And sometimes that's a little more useful than just figuring out what's the mean, median, or mode. Sometimes we just need this one number, this MAD, comparing this and saying, okay, I had a MAD of 2, that's pretty small. They had a MAD of 20, almost 23, that's huge. This just tells me that I was more consistent, my data was closer together, and my cousin was all over the place. They had high variability. And now it's up to your grandma to decide what that means and who's the better saver. But this week we are going to work on this idea of MAD, the mean absolute deviation. It's a measure of variation, and it helps you understand, okay, find the average. So that's obviously going to be an important skill this week. You have to understand that you add things up and divide by how many there are. But then once you get the average, you're going to find how far everything was. So when you're done writing this down, you're going to click mark as done. And then either today or tomorrow, when you move on to the next, there's a little MLE practice. Talks to you about the 6 fastest birds in the world. The very first thing you're going to have to do is find the mean of those birds. So add up all their speeds and divide by 6. Do that part really carefully, because if you mess up the mean, you can see, obviously we use the mean for all the rest of this. So if you mess up that very first part, all the rest of your answers will be wrong. So be very careful on that bird question that you're going to try next. Add up all 6 of the speeds, divide by 6, and then you should be able to do the rest from there. So this week is MAD. Please email me if you have any questions. Good luck, guys.